when you do these transformations, make sure x is positive, and the plus 3 is actually 3 units to the left. Okay, students think that means 3 to the right because plus means positive, means going to the right, but it actually means 3 units to the left. So let's take this starting dot. Well, it's not really starting dot. We can call it the cusp. This plus 3 means we go 3 units to the left of the original place. And then a plus 2 is a vertical shift up of 2 units. If that's a minus 2, you go down 2 units. And that's it. We've got the cusp graphed. But the negative x means we've been reflected about the x-axis. So it should be looking something like this. So to figure out what the next point is, let's use this dot right here. That's 1, 1. If we move that 3 units to the left, 1, 2, 3, then 2 units up, that would be down here, but it's been reflected by multiplying by -1. So it should be 1 unit down here. Okay, I think that's it. Here's the other way of doing that, okay, if you weren't sure what I just did there, because I guess I didn't explain very well. But look, 1, 1 is a dot in the original graph. If you plug in 1 into this function, 1 plus 3 is 4. What was f of 4 of the original graph? So 1, 2, 3, 4 in the x-axis. That's a little too high. That's not going to work. So let's pick another point. How about we do -1, 1? So if you plug in -1 in here, -1 plus 3 is 2. So what was f of 2 of the original graph? So if you go over to x equals 2, it's got a y value of 4. So this is going to be -4 plus 2. So at x equals, when we plug in x equals -1, we got out y is 2. I forgot. -2? No, that doesn't look right. I forgot. Here, let me write it down. Okay, so what you want to do is just pick a value for x. It actually really doesn't matter. You can pick any value. Let's do x equals -1 again. Okay, so for the transformation, it's supposed to be negative f of -1 plus 3 plus 2. And remember, f of x is the original dotted graph. We can get values from that. So -1 plus 3 is 2. F of 2 that means the y value when x equals 2 on the original graph. So here's where x equals 2. The y value is 4. So this is 4. So -4 plus 2 gives us -2. So we should have a dot when we plug in x equals -1. Oh, that's over here. That's why it looked wrong. So when x is -1, the y value should be -2. We've got that. Okay. Okay, so Newton will only let you do it a certain way. So originally I was doing this by picking some points and graphing it, but you have to graph these dots. Like this is how it's kind of set up. They want you to shift this dot a certain way. Let me think about what to do. So you always want to have this x as a positive, with a positive coefficient. So in other words, you want to factor out the negative sign. So that's -x minus 4 plus 3. Okay, and the reason is because now you can identify the horizontal shift. This -4 means you shift it 4 units to the right from the original place. The plus 3 means you go up 3 units from the original place. Okay, so that's the cusp. We've shifted the cusp. What was it? 4 units to the right, 3 units up. So the negative sign that we factored out is just meaning it's going to be reflected about the x-axis. So to find exactly where that dot's going to go, look, when I'm shifting this around in Newton, and this is the frustrating part because we have to do it Newton's way. When I'm shifting it around, they want a y value of 6, right? Every y value of these dots is 6. So we want to plug in 6 in here for y. And you could have the this version, or you could do it with the original version before we factor out that negative sign. Okay, so to solve that equation, You can subtract 3 from both sides, so we get 3 is f of negative x minus 4. So there's some sort of x value. I'm going to distribute that negative sign now that we've taken care of shifting the cusp. That's negative x plus 4. So there's some sort of x value we should be able to plug into the original function to get out y equals 3. If you go to the original, this can't be what they want. This is a crazy way of doing it. So it looks like if you plug in 3 in for the x, you should get out 3 for y. So we need this inside to equal 3. So negative x plus 4 equals 3. So subtract 4, negative 1, so that's x equals 1. So let's see if that's right. So x equals 1. That looks right. Okay, here's another way of doing it. Look, once you've shifted your cusp, like I taught at the beginning, to get this dot correct, look at the slope of this straight line. It's rising one to the up one to the right one, up one to the right one. We need to make sure our slope still is up one to the left one, though, up one to the left one, because of that shift, because of the reflection about the y-axis. When you multiply by a negative, you've reflected about the y-axis. Like, for example, if you had y equals x, that graph looks like this, right? But if you multiply this by a negative sign, then the graph has been reflected about the y-axis. It's going in a different direction. So that's the same thing. They had our dot over here, but since we're multiplying by a negative, we know we're supposed to be reflected about the y-axis. And I know this is the right dot because it has a slope of negative 1. This wouldn't be right because it has a slope of negative something other than negative 1. Look, this is a slope of 1, so our reflection should have a slope of negative 1. That's a tough one. I hope that's the hardest one.